Okay, questions? Questions? Which one? From the my questions or from the Moodle? Huh? From the Moodle. Which one? Okay, I guess I got to go to section A, right? Where should I go? Okay. At the top? Okay. Exam resources. Okay. Okay, which one? The first one. Okay, go to solution version. Okay, which one? 14, 1-4. Okay, let's have a look. Consider the following method determines if numerical grade is equivalent to a letter grade of A+. Okay. Okay, greater than or equal to 90. Okay, that'll be A+. Okay, parameter. Okay, so of course you should really know how to read the Java docs, right? You have seen parameter and return value for sure. Did you see anything about pre in the lab? Maybe you did, right? Okay, it's called precondition. As I explained last time, precondition simply means it's something that you don't have to check as an exception. You would just assume that's the case, okay? You might need a precondition when you want to justify either formally or informally whether your method itself is correct, reasoning, okay? Just keep that in mind. The grade is less than or equal to 100, okay, which means you can only give value between 0 to 100, something like that, okay? Okay, which of the following value of grade would be considered as boundary cases for the method is A+, okay? Okay, basically thinking this way, okay? So now we know that for this particular method here is A+. According to the definition here, A+ would be greater than or equal to 90, okay? Conceptually, that's how you can think about it, okay? If this is a number line, okay? Let me draw a little bit better. Let's say this is your number line. And then somehow we have over here. Okay, let's just go through the case a little bit. First of all, the precondition over here is the grade is less than or equal to 100. So that means it's something you can assume, okay? The grade is less than or equal to 100, okay? If you think about, let's say this point over here is 100, okay? So basically, any value is kind of possible over here, including 100, you assume. You wouldn't have to test 101 because it's not covered, it's outside the precondition, okay? So now 100 over here is, if you think about add pre, okay? Something you can assume. Assume input is never greater than 100, never ever. Okay, so you don't have to test them, that's why it's a precondition. On the other hand, if you get add throws, on the other hand, if you got something like this, throws, and then you say, for example, illegal argument exception, okay? When, for example, the grade is strictly larger than 100. In this case, it will be different from precondition. In that case, you are expecting your code to actually throw the exception when this happens, right? Okay. In this case, you will need a test cases. Okay, it's different. Okay, and then the method that we are trying to talk about is whether that's A+ or not. So let's think about the definition for A+. It's saying that it's either greater than or equal to 90, right? So talk about 90 here. That's another point. So let me put 90 over here. Okay, that's the point. So we are basically talking about from here until over here, from 90 to 100 inclusive, right? So that would be A plus. Otherwise, if that's strictly less than 90 and less, that'll be non-A plus. Right? So that's kind of the cases, right? So you basically boundary cases simply mean you want to go close to the cutoff points, like a 90, for example, right? So that's why if you go back to the answer, 89, yes, 90, and 100, right? 89 is basically right over here. It's very close to here. And also 90 is right on the boundary. Okay? And also if you talk about 91, it's also very close. When you talk about boundary cases, that simply means very close to getting things either A plus or not A plus. As long as they're close, that's boundary cases, right around the boundary. Okay? So that's the question. I think it's good that you asked this question here. So in the exam, as I said last time, you don't really have to write JUnit test cases, although you'll be a very good practice beyond this course. Okay, that's another story. But in the exam, you will be given a problem like this. Like, for example, we talk about how to test the Dell keyboard, right? This one is actually easier. So you only talk about is A plus. We can do another one right away. Okay, I'll point out something to you. In this case, normally it would just ask you how many test cases did you need in order to really reveal if there's an error in your method. In this case, he just tells you what should be the boundary cases. I just showed to you. Okay, let's talk about another one. Okay. Okay, we're okay with this. Let's do another example here. Okay, let's say this. Let me say I'm going to write a Java doc. Okay, 2-star over here. Okay, let's say we talk about it might be interesting to think about 2 parameters. Okay, what can be the 2 parameters? Oh, how about absolute value? Let's say, make it easier, just integer. Okay, integer absolute value. Okay, do not worry about overflow. Okay, integer x and also integer y. And of course, this will be your implementation. Okay, I'm going to omit. All you got to do is a software tester job. Okay, you don't have to worry about how it is implemented. Okay. So now over here, so what you would say is things like at parameter, you can define x, that will be the first number, and also param, also y. Okay. Okay, like that. And let me do a little bit, like just show you about a precondition. Okay, I can say at precondition. The precondition is we assume 1 less than or equal to. Let me just write it a bit more math. Let's say x is in between 1 and 5, and let's say y is -3 less than or equal to y, and less than or equal to 10, for example, right? I'll just make it up, just to get an idea. Okay? We'll talk about this test case in general. Let me just make the range a little bit smaller, so we can talk about it, so you can know conceptually what you should really test. Let me just say 2, okay? Just smaller. So now, in order to test your absolute value, of course, the assumption is absolute value, the return value should be positive, right? At least it should not be negative. It might be 0, but it cannot be negative, okay? So now, how many test cases do we need in order to calculate this, in order to test this? How many? 2? Okay, if you believe that's 2, why do you think that should be 2? Why don't you give me the test cases? Okay, so you're suggesting only 2 test cases. I'll write it down first, and then we will talk about it. Okay, you're talking about absolute value. Okay, give me a suggestion. 2. Okay. Sorry. Well, what about y? Just 1. Okay, I'll say 2 and 1. And then give me another one. 4 and 0. Okay, let's talk about this, okay? First of all, let's think about whether these 2 test cases are complete. And whether that should be complete or not depends on whether you're missing some scenarios, okay? First, okay, I can tell you easily why it will not be complete. You can see over here, x is strictly larger than y. So that means if you simply just do subtraction 2 minus 1, it will just give you the value, right? Which two? You mean this one here? Yeah, that's something you can assume. Yeah, sure. I'm just trying to say, if you only say you get it has 2, 1, and also 4, 0. Here's my question for you, okay? Remember what we said before. To really judge to see whether your test cases are good, you want to see these 80 missing scenarios from your test cases, right? When things go wrong. Let me just do the following. Hypothetically, can I say the implementation here, I'll simply say x return x minus y. First of all, is that a correct implementation? Is it? Well, there's no partially correct. Just tell me either it's correct or not correct. It would be incorrect if you can find me x and y such that applying this implementation here will give you wrong value. So do you think this is incorrect?
Yes.
Incorrect. Can you give me examples for x and y, which will show this error?
Y is greater than x.
Yep. Oh, another possible exam question could be, let's say I show you this particular implementation, and then I say, consider the following test cases. Which one can reveal errors in this implementation? Okay, let me present you exactly like that. Maybe one of your exam questions is like that. I mean the past exam. Okay. Okay, let me just let me change the question to be more interesting. Let's say return x minus y. Let's say that's what we have. Okay. So now the question is, okay, I'll phrase it precisely. Which of the following tests would reveal an error in the implementation? And when I say the implementation, I'm talking about this particular implementation, right? So now let me just repeat what you said, okay? Option A, calling absolute value 2 and 1. Option B, absolute value 4 and 0. Okay, they're all value, okay? Option C, let's say absolute value over here. If I get, let's say, 2 and 2. D over here, absolute value over here. Let's say I got 1 and 2. Okay? Guys, can you see what the question is? First of all, I think for this one, it's more important for you to understand what the question is asking. I think that's more important. I'm pretty sure absolute value is not in the exam. I'm pretty sure. Okay. So now it's more important for you to understand this. Okay. The answer should be D. Okay. And the reason is by executing this particular test to this implementation here, you're going to return, okay, 1 minus 2, which will just be minus 1. Minus 1 can simply not be an absolute value, so this will reveal an error, okay? And YC will not reveal an error. Yeah, 0 is fine, right? 0 is just correct, so that wouldn't reveal an error. Just want to double check. Okay, just another example for you. Okay, that's the first one. All right. Yes.
Going back to the boundary cases.
Yes.
What would happen if we were to use double instead of the int?
Oh, interesting, Kate. If you think about boundary cases for double, I would say it's a bit trickier. Okay, but I would say when you're trying to test for double value, you can start with just treat them like an integer. You just go for the boundary. For example, let's say this. I'll give you a very simple case. Let's say you're simply trying to do things like, let's say double over here, and then you say area. Well, that's something we did in a class, right? Area, and then you would say double radius. Okay? So now, of course, you're going to get some implementation here. I'm going to omit. Okay, Let's say we are making the precondition over here again. So keep talking about precondition today, so you have more exposure to it. So precondition, okay? Let's say radius is non-negative, which means it can be 0, positive, okay? Non-negative. Let's follow the same logic as that question you saw on the exam. Which of the following tests will be considered as boundary cases? Which of the following tests would be considered as boundary cases? Okay, let's see. Let's say A here, maybe minus 0.5. B over here, let's say it's, let's say 0.3. C here, minus, I don't know, 0.8. Okay. D, all. E, none. How about that? Okay, it's a typical 5 choice, right? Okay. Okay, take your pick. I guess you might be a little bit struggling with, should I include A or C or both? Maybe, right? Okay. I would say in this case, if I were to design a question, I would say A and C are both boundary because they're sufficiently close to the boundary, right? You pretty much agree the boundary should be 0 in this case. So as long as you choose something very close to 0, it's okay. Okay. For completeness, let me add one more thing. Okay. Of course, the real boundary, which I didn't include, I forgot. If you don't mind, I'm just going to add set over here. Doesn't matter. Okay. Just before that, 0. 0 should be a boundary case for sure. Okay. So now I think the answer should be all. On the other hand, what would not be a boundary case? For example, if you include 10.2, that's not really a boundary. That's too far away from the 0. Okay, it's not really a boundary. Okay, you pretty much get the idea. What's the best way to solve this kind of question? If you're really talking about numbers, you better just draw the number line to see where the points are, so you can see the boundary. Yes.
Why would that be a boundary case? You said all of them would be a boundary case if we already know that the condition is not negative.
Oh, non-negative means larger than or equal to 0. Oh, okay. In case you're a little bit struggling with this, okay. This is how you can think of it. Negative means less than 0, agree? And we're saying it is not the case less than 0, which means it's larger than or equal to 0. So we basically got to consider everything starting from 0. Oh, I see what you mean. Okay, first of all, you know what? I think I just missed something over here, which I confused you guys. Okay, let me take it back a little bit. Okay. If the case was, we say precondition over here, that means we assume you will never be called anything that is not this case, right? So that means negative does not need to be tested, number 1, okay? So now, in order to make this question more valid, okay, I would say hypothetically, let me say this. Okay, let me get rid of it. Let me put it here. I would say at throws. Illegal argument exception when radius is negative. So now the question becomes, it will make sense, because why should you test for negative? So you want to make sure when you call this method here for area with negative radius, you should really get the illegal argument exception. Okay, so now that makes sense. Maybe that's what you're concerned about. Okay. Okay. Questions?
How much can you vary that boundary case by? Like, what is the upper limit of
Yeah, I don't think you should really worry about the absolute limit, like how far should the boundary, actually it should be sufficiently small. Yeah.
less than 1?
Yeah, I would say less than 1 is about fine. Yeah, yeah. It's not really like a definite, right? I would say as long as the value is close enough, I think it should be considered as boundary. I think in the exam, we wouldn't trick you like that. I think as long as you believe that's small enough, that's boundary case. Okay. Okay. Yes.
Last sample example we were looking at previously today, question 10 talks about critical interface. And
Let me just go there first. The same exam, right?
The first one.
Okay. This one here.
Yeah.
Okay. 10. Okay.
so I understand one seems to be correct, but for D, is there
I think, okay, this one basically simply means when they say is equal to, they're more talking about the equals method. When you say x, okay, yeah, I'll write it down. Let me write it down and then I will switch to iPad. Compared to y must return 0 if x is equal to y. Okay. That's what it says. Okay, I think the main part to clarify is this. When I say x is equal to y, I'm basically talking about x dot equals y. Should return true, right? Not necessarily. Remember, we got lots of flexibility for equals method. Number one, you can just leave the default version, which you compare references. So when you say return 0, not necessarily when the references are equal, right? And also, it's completely up to you how you can redefine the equals method. So you can definitely find some kind of example to this. It's a bit tricky, I know. Yeah. Okay, so how about this? So tomorrow when you answer the multiple choice, choose the best answer in case you have doubts. Or, put it this way, some questions there, maybe, let's say you got 5 options there, you find that, I don't have enough time to figure them out. Maybe you try to get rid of answer that certainly cannot be correct. One strategy which I used to use when I was a student, I'm not sure if that'll be applicable for tomorrow. Let's say somehow, for example, right? Let's say the answer actually got A, B, C, D, E, for example. And then let's say somehow the solution basically got, each option got 2 parts, okay? Let's say you got part 1 and also part 2. Part 1, also part 2. Part 1, also part 2. It seems like you got maybe 10 different things to consider. Not quite, I would say. Maybe consider just maybe the first part first to see what the answer should be. Somehow you realize they're only, you're pretty sure this part, maybe answer should just be C, for example, right? In that case, you can just filter out. So these are the only 2 things left. And then, based on these, you can look at these 2 options only. Right? I'm just saying some strategy. Could be useful. All right. Yes?
One of those lessons like this one with like compared to or other methods
Yeah.
override, if it doesn't specifically say that it's been overridden, do we just...
Oh, good. I would say whenever we talk about equals method, because it's possible you either have overridden it or you have not. If we didn't say, you got to consider both cases. That's what it means.
With compared to, I know, I forget exactly, but did we do an example where we kind of switch things around because the order?
Yeah.
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 So in this scenario, in this question, it is assuming that it's just like the default version compared to.
Oh, that's that one there. Okay, I think that one is more talking about just in general, what you should have done, basically. So if you look at the options again, right? So over here, they say, what would be true about the expression x that compared to y? So now it simply says certain type. It didn't say any that oh, you know what? As soon as they say an instance of a type that implements the comparable interface, so that suggests to you that compared to method has been overridden properly already. It has been overridden. Yeah. Remember, okay. Again, might be nice to review just a little bit. So what we said in the class previously was like this. Okay, so now if you think about, there's a class called comparable. Oh, comparable, right? And that one, there's an interface. And now, in order for me to use this comparable, like a point, right? Also, we talk about point being interface. For example, I can say now I have maybe my person class over here. And then over here, comparable has only one abstract method for you to actually implement, right? But we don't really say abstract. So that would be something like this. You have compare to, which returns an integer, and then some object over here, okay? Okay, it's header only. And then in the person class, of course, you must declare also compare to in order to make it work. What we assume in that question there is you put something here that's valid. But what exactly you put it there, we don't know. It can be anything. Okay. Also similar for the is equal. Is equal like an equals method. You cannot assume whether it has been overridden or you have not been overridden. It depends. Yeah. Yes. Okay. So you mean when you are asked to write a code in the exam, right? Okay. So the question was, let's say, for example, if the question was about, now define this person class. Let's say we give you a person class, the empty one. And now you want to make sure person implements comparable. In that case, when you redeclare this compare to, do you have to override over here? That's your question. You don't have to. Okay. So override is mainly just for Eclipse. So I would say for the exam, it's optional. If you write it, it doesn't hurt. If it doesn't write it, you wouldn't get any marks deducted. Yes.
So on chapter 4, slide 26, I believe, it's more about a comparable.
Okay, let's go there. Okay, it's about a comparable lecture. Okay, let me just go there first, and then we'll talk about it. Okay, and then can you tell me the slide number? 23. 26. Okay, what about it?
So it says how would you use the comparison method for the third lesson of rock paper scissors game and for the hint and transitivity?
Uh-huh.
Well, let's say rock is less than paper and paper is less than scissors. Then would that not imply that rock would be less than scissors, which would not be correct?
Okay, think about this. Okay, basically we're talking about this particular extra exercise we talk about for the comparable, right? Okay, so why can we not make the player of a rock paper scissors game comparable? Okay, the reason is this. Okay, so first of all, rock larger than scissor, right? Okay, scissor is larger than paper. By transitivity, we should have rock is larger than paper. But is that the case? No, exactly. In order for compare to work, transitivity must work in a valid way. However, right here we try to apply the rule using transitivity. The conclusion we will make is if you try to apply this, what you will get is the rock is going to bring over paper. But that's not a game we are familiar with. So, of course, it's not valid. That's the point. Yeah. Yes. Oh, you're fine. Okay. Question. Yes, I can even tell you you're going to be required to implement recursive method. Yeah, because for our section we haven't really tested you about writing recursive method. So I think so you got to get prepared for that. Yeah, and what's the best way to get prepared for this? Review the example we did in the class. First of all, review the solution for lab number 6. You wouldn't be required to write something like something as complicated as maybe like a merge to sorted list. It's not as complicated as that, okay? But it doesn't hurt to review. If you got spare time, go to coding bed and do more exercises. If you have been doing that, that's good for you. Maybe to review that a little bit. If you haven't, you still got time. It's 9 a.m. tomorrow, right? Okay, you got time. Yes.
Okay, so for the practice one that you gave us, so for the...
You mean recursion and correctness proof?
Not the correctness proof, but where you have the triple nested for
Oh, you mean the asymptotic analysis? Yes.
Last class you gave us an exercise where you changed it up a little bit.
Uh-huh.
Do maybe go for that.
Go over that a little bit? Sure.
You only changed the condition.
Okay. I can briefly talk about it. Yeah, no problem. I got to remind myself what I changed that into, but let me just bear with me. I'm going back first. Over here. Good. Okay, no worries. Let me copy a new page. Okay. I'll start from scratch. Okay, bear with me. I'm going to create a new page. Okay, let's say this guy over here. Okay, so basically what you just got to talk about is like this. I can give you a little more hints over here. Let me just clean it up a little bit. So I meant to say k larger than k plus equal 2. Okay, which means somehow the speed of incrementing k gets double the speed, basically, right? Is it really gonna change the asymptotic upper bound? That's the only thing we're gonna see. It turns out maybe not. Why not? Okay, I'll give you a little bit hints over here. You can try. Again, what you want to do is to say, okay, I'll just go for when I is equal to 0. Okay, when I is equal to 0, in that case, 0 all the way to n minus 1. Okay, that's the overall picture. And then I'll go for j. J is going to be from 0 until n minus 1. Okay, let me go a little bit further because we want to see some meaningful value for k. Okay, let's say for this. Let me go a little bit further. Let's say I is equal to 4, for example, or even 10. And j will just be equal to 10, 11, all the way to n minus 1. Okay, so now the question is, what would be k, right? That's our question, okay? So now for the case of k over here, it will be plus equal 2, and then initially j. So that means k will just be, first of all, it will be 10, and then 12, all the way to n minus 1. Okay, agree? And this will be 11, 13, and then all the way to n minus 1. And this one will be somehow n minus 1, and also maybe just that, just n minus 1. So the way to see that is, give you a little bit hints. Somehow you will be able to judge. I'll just put it down informally. You can work out the math. For each value of k, okay? Oh, sorry, for each value of j. I'll write down a conclusion you should get. For each value of j, the number of iterations for k is roughly big O of n over 2, roughly speaking. Because you're doubling the speed. But how do you exactly get to n over 2? Try to do a little bit more unfolding, and you will see that. Okay. I hope that helped you a little bit. I hope. Okay. Okay. Work out the math. That's my point. Okay. Well, let's say, before I get to you. In the exam, let's say you are really stuck over here. Just write down what you believe intuitively, right? Maybe the TA will be so kind to give you a little bit partial marks. Yeah. Maybe the TA is more kinder than I am, but we'll see. Yes? Oh, I see. You say j is equal to 0. Okay, good. If you change this guy here to 0, okay? The answer is it will not change asymptotically because this actually go back to the easier example that we talked about before. So, which means everyone is going to be just n rather than, right? Yeah. It's more like this. If you try to do n plus all the way to n, and let's say you got n terms, it's quite obvious, n squared, right? It's no-brainer, okay? In the case where when you say j is assigned to I, it's more like this. It's more like n plus n minus 1 plus all the way to just 1, okay? In that case, you're just doing arithmetic sequence, okay? In that case, you will just get n plus 1 multiplied by n divided by 2. Asymptotically, it will still be big O of n squared, so it's the same, okay? If you see the mathematical insight, it's really like that. Okay. Did you guys review aliasing, tracing the code, things like that? Okay, I presume you're okay. Yes? Shallow copy and deep copy, yes. You should know what the composition is. So to really do that, maybe you want to review a little bit about copy constructor. Yeah. The best way to do it, oh, you know what you should do? First of all, review the example about directory that we talked about in class, right? About why one version is not good, the other version, by fixing the copy constructor, it will be good. One thing. Number two, maybe look at the programming test. I think I gave you 2 programming exercises, right, for a programming test 2. Look at the first one. When we talk about the point, line, and etc., look at the composition version. Yeah, that will help a bit. Do you have to know the diagrams of the arrow? Okay, okay, no, you don't need to. Okay, it's only for your knowledge. You don't need those diagrams very badly in 3311, just to let you know. But you worry about that when you get there. You guys seem to be very confident, maybe? Okay. The exam may not be so easy, so stay calm. Just do your best. Want to prepare you for that, right? But don't panic. You know, everybody will feel the same, so just do your best. Okay. I'm glad I'm not the one who was writing the exam. I'm glad. Well. Yes? Yeah. Oh, searching? I would say, oh yes, good. About searching, I'll make the following suggestion. Okay, searching. Okay. For the searching, of course, you should know how to do a linear search. Basically, just run a for loop, right? And understand why it should be big O of n. That's easy, okay? Number 2, binary search. That's the only other search we talk about, binary search. And when you review the binary search, you want to do the following. A, the code. Understand how it works. You don't really have to write out binary search in the exam. But, for example, you might be given something similar to binary search in the multiple choice, or you may have to write something similar to binary search, but you don't need to write per se binary search. Okay? So to get yourself familiar, okay? And also you want to know about the running time. The running time, there are 2 parts. One is about how you formulate, right? For example, you would say T of 0, right? 0 means empty array, right? In that case, that would simply be just 1, means constant time, okay? And also, if you got T of n, it will just be T of n divided by 2, because we are halving the size of the array, right, each time, okay? And plus 1, something like that. Okay, formulate and also solve recurrence relation. And actually, for this part here, I'm not just talking about binary search specifically. Maybe you want to review the example we did in the class. That will be sufficient. Okay. Especially look at the linear one, right? The linear one, the log one. Okay, that should be enough. And also for C over here, correctness. Okay. Think about base cases for binary search. Why is that correct? And also think about also recursive cases. If you go to the left, why would that be correct? If you go to the right, why would that be correct? What's the insight to the binary search? Just to ask you about. If this is the array I'm talking about, okay, I'm just reminding you of some necessary details. Let's say this. This is my array. This is from, and this is to start with, okay? And we know that we calculate the middle index, which will be from plus 2. Oh, let me write it a little bit better. From plus 2 divided by 2. That's the middle, right? Let's say the key that we want to search for is k. Search for k. What we will do is we're going to compare this particular element against k to see which is larger, right? Okay, for example, if I know that k is strictly larger than 8 at position from plus 2 divided by 2, or just middle. Now, question for you. Conceptually for binary search, if I know that I haven't found a key yet because it's not equal to, if key is strictly larger than the middle elements, should I go to the left, right, or both? Right? Why should you go to the right? Why do you, okay, here's the thing. Let me write it down, okay? If you don't know what we are talking about, you better review, okay? Okay, so now I'll put it here. If we call, in that case, I will simply say binary search helper, right? Let's say that's what we're talking about. And then over here, we'll simply say the same array call by value. And if I just make this, just call m for middle, okay? And then here, I should really say m plus 1 and then 2. Okay, that's if you look up the code, that's how it is specified, which means we are now focusing on this particular subproblem over here. So now here's a question. How do you argue we are not missing any elements from the left? Okay, let me write it down. Why is this call not to miss k in this particular region? Because we only recur on this side, but not this side, right? Okay. So now in a from, and also a from plus 1 all the way to a middle minus 1, right? So this is a question for you to think about in order to prove the correctness of binary search. This one here. Okay, why is that? Well, as you said, because we assume that it's like a precondition. In order for you to do the binary search, the array must be sorted, right? So it's guaranteed. If k is strictly larger than the middle elements over here, so it's guaranteed. Only those that's strictly larger than this one can be the candidates for where k is stored. Not here. Okay, it's just not possible. Just not possible. Okay, something you want to be able to express yourself. Okay. Yeah, searching and sorting. For merge sort, just to get a general idea, that'd be okay. You definitely wouldn't have to write code like a merge sort. Okay. Yeah. But in terms of solving the recurrence relation, I would say if you're able to do binary search, that'll be very good. If you're even able to do the one for merge sort, which I included for you in the slides, if you can do it by yourself, I think that will be, you're definitely prepared for that part, okay, to solve the recurrence relation, just to unfold. Yeah.
Time complex the t to the n over 2 plus 1 still not n?
This is not n. This will be log n. Yeah. The idea is eventually you want to get to just 1. Eventually. Yeah, you can look up the notes. Yeah. Yeah, so I think for this part here, basically this part, this is not going to give you big O of n. It's going to give you big O of log n. It will be. Why? The idea will be every time you try to unfold the recurrence relation for one time, you had to half the size of n. How many times do you have to unfold until you get to just 1 or 0? Well, log n times. Okay? In case you're a little bit uncomfortable, let me just refer you to this very quickly. Okay? So remember in the very last lecture, okay, let me just show you that. In the very last lecture, we did this particular unfolding together with you. Okay, remember? That's a binary search. Anyway, look it up. Okay, you can also watch the recording for that if you need it. Just only 5 or 10 minutes. Okay. Okay, good. Let me go back here. Okay, any other questions? Yes. Mm-hmm. Okay, sure. Just some constant time operation. Okay, apparently this one here is just big of 1, right? So now again, you will have to do a little bit of pattern analysis over here. This might be a little bit too difficult, I would say, yeah, for the exam. Okay. But give you a little bit idea. You can carry on. Okay. Think about over here, I would just be 1, and then 2, and then 4, all the way to, let's say, all the way to n, okay? All the way to. So now the idea would be, actually this, I'm not too sure. Let's see. How many have we got? How many exactly? Okay, should it be n over 2 or log n? Okay, I'll give you a little bit more hints. What would be the one after 4? Is it 8 or 6? It's always actually 8, right? Or it's every time 2 times, right? 8 and then 16 all the way to n, right? You're right? Log n iterations. And then for each value of j, you can now do the pattern analysis as before. Is the answer n log n? Exactly, n times log n. Oh, actually, it's not too bad as I thought. Okay, so now once you get your answer, I'm even more confirmed. Okay, good. Okay, guys, for this one here, okay, here's how you can think of it. Okay. Again, we try to solve this problem here using the same pattern. Okay. Think about the change of the pattern for the loop counter. Okay. So that's why I want to do a few more examples to confirm. Starting with 1 here, and then 2, and then 4, multiply by 2, multiply by 2, and also multiply by 2. Or you can think about it's like a 2 to the 1, 2 to the 0, 2 to the 1, and 2 to the 2, and also 2 to the 3, all the way to 2 to the power of something which will be equal to n, log n, right? Okay, that's why I got log n iterations for the I, okay? And then let me do a little bit more. When you talk about the value for j, you'll be similar to how we did it in the class, and now we go back to what we are familiar with. Let me just do 1. Okay, so let's say j will be, let's say 0 and then 1, right? In this case, because initialized to be 0 and less than or equal to I, okay? And this one will be 0, 1, and 2. This will be 0, 1, 2, all the way to 4. And less than I, doesn't matter. Yeah, now, you're saying this, right? Yeah, it doesn't quite matter, asymptotically. But let's say less than or equal to, okay? Okay, and now this will be from 0, 1, 2, all the way to n. So now you can do the arithmetic sum, right? So that's n log n. Okay, this one's not too bad. Yeah.
So what if we wanted to have something recursively calculate a Fibonacci sequence?
To recursively calculate the Fibonacci sequence. So is it from the lab or?
Someone just threw it as an example.
Is it an example? Yeah, maybe you mean to really determine if the sequence is Fibonacci or to generate Fibonacci sequence?
To generate a Fibonacci.
To generate Fibonacci sequence. Sure. It's actually from previous year lab, I think. Well, maybe. It's quite a common problem. Okay. Let's say this. We know what a Fibonacci sequence, right? 1, 1, 2, 3, 5, 8, etc. Right? So this will be the sum of the previous two. Okay? So now here's the problem. Let's say we want to do integer array over here. Let me say fib, just for Fibonacci sequence. Okay? And then integer I. Let me just put it n. N simply means the size of the Fibonacci sequence we want to generate. So n could be 0. Oh, the precondition. Okay? The precondition. N larger than or equal to 0. So now, what would be the boundary case to test? Do you have to test for -1? Well, it's precondition, right? So you don't have to test the illegal value. You assume it is the case. Okay? Okay, it's a precondition over here. Okay, so that means assume n is not negative. So no need to test when n is equal to -1, -2, and etc. On the other hand, if I rewrote this to say add throws illegal argument exception when n is actually less than 0, in that case you have to test it, right? It's different. Okay, let's go back to the question itself. So now over here, how do we implement it, right? I'll give you a little bit hints. This one is not too bad. The idea would be you want to basically create an array. Let's say this. If I just give you 5, for example, right? What would be the size of the array I want to eventually return? 5. Why don't I create an array first? Okay, 1, 2, 3, 4, 5. So the first line, I can simply say integer array, the sequence will just be a new array, and then just n, whatever n it is. Okay, I'm going to do something over here in a moment, and then eventually I want to return the sequence. So the pattern is very similar to what you did back in the lab. Okay. So now what we can do is, the idea would be we want to do pass by value, call by value. So you can think about sequence over here is pointing to this particular array. Okay. The idea would be for each recursive call, we want to fill in one element at a time and then keep moving, basically. Okay. But before we pass in the recursive call, we want to have something to start with. Okay. So why don't I try to fill in 1 and 1 over here, and then I will fill in the rest by using a recursive call. Okay. So what I can say is I can say if, for example, okay, over here you want to be a little bit more careful. I'll tell you what you should be careful about, and then you should really write the code yourself. Okay. If I simply say integer, oh, sorry, not here. Okay, let me say it again. If I say sequence over here at position 0 is assigned to 1, and also sequence at position 1 is assigned to 1. Okay? Would it be okay if I write this right away? Why would that not be okay? Yeah, exactly. So what's the problem for this one is this, okay? That's why I want you to fix the code yourself when we finish the session. The problem is, oh, anything? Okay. So now let's say if I simply say 1 over here. So that means the array size will just be 1. So now do you have index 1 for array size 1? You don't. Okay, you gotta be careful. You may want to use if conditional. Okay, let's say you can do that, okay? And then what I would do is I will simply say, I'm gonna call helper. Fibonacci sequence helper. Over here, I'll pass the same sequence over here, okay? Call by value. And then I'm just going to fill in some helper index for me, okay? Maybe I can say from and to, okay? 0 and then maybe, oh, sorry, not 0. So now since we have done these two already, right? These two are done. So we're starting from 2, okay? So now what I will do is I'll do 2 over here, and then all the way to sequence the length minus 1. Okay, from and to, right? That's something you're familiar with. Now the question is, how do you define that recursive helper method? I'll write on the header for you. In that case, question for you. What's the return type for this helper method? Does it return integer array, or something else? Void, yeah. You can see what we are doing here. We are basically passing the sequence here, right? That's the key. In case you have any confusion from the lab solution, okay? The most important thing for you to realize is this. When I'm trying to call this particular helper method, I'm passing sequence into here, call by value, which means every recursive call we are ever making, they are basically pointing to the same array. We're just modifying different elements one at a time, okay? Call by value. That's really important to realize, okay? So now if I write down the header for you, let's see what's going to happen. So void. Fibonacci helper, okay? You can say integer array sequence. Let's just repeat the same name. And also we got integer from integer to. Okay, the rest is up to you. Yeah, I did about 30% or 40% for you already, but you can do the rest. Okay. The rest would be something like, since we're starting from index 2, so now it's guaranteed always have the previous 2 elements for you to add up to the current one, right? Yes, question. The header? The helper, I would say, in case we give that to you, you should just follow that. In case we didn't give that to you, you're completely free to how to define a header. Okay. Yes, that's most likely the pattern. Yes, but if we give you any recursive helper method, recursive method to implement, would be very clear about how it is supposed to work. Yeah. Mm-hmm. Yeah. Again, every time you want to implement a recursive method, think about the base cases first, okay, and then just somehow write down the pattern, right? It will be just a few lines that might be a little bit different from this method here. Okay. What will be the time complexity? Oh, good question. Guys, what will be the time complexity for this? You don't need to justify formally, just intuitively. Log n, quadratic, n cube. It's okay, just speak out. You know, it's okay. You think that's n? Why would you think that's n, intuitively? That's okay, just asymptotically. Okay, which I'm calling here, right? Yes. Yeah. Yeah. Mm-hmm. Let's say initially here, yeah. Mm-hmm. Mm-hmm.
then you're strictly looking at F19.
Exactly.
So then the high scenario would be
Yeah, something like that. Basically, the idea would be I fill in these two things first. That'll be constant time. Okay, and then each recursive call is going to do a subproblem over here, and then I'm only going to fill in this particular slot. In the next recursive call, I'm going to consider this particular sub-range and then only fill this in. The next one, fill this in, right? So reduce the problem size by 1. Okay. So the recurrence relation, if you're interested, will be T of 0, empty array, right? 1. T of 1, also 1. T of 2, also 1, because it's like a 1, 1. Okay? And T of n, anybody want to give it a try? What would that be? Should it be n divided by 2? Not really, right? If you say n divided by 2, that means you're halving the problem size, which will give you log n. That's not the case. N minus 1, yes. The reason is, over here you can see, let's say I'm currently here, and then I'm filling in this particular element, right? How do I make another recursive call? I would say from plus 1. So which essentially considering a subarray over here. The problem size is reduced by 1, okay? So what you would say is something here. You would say T of n minus 1, and then, of course, the copy itself would take some constant time, right? And how do you solve this? I'm sure you know how to do it. Okay. Yeah, so it turns out the running time for this is basically identical to the all positive that we talk about in the class, right? The same. Basically, you're scanning through the array. Okay. Yeah, we still got lots of time, but if you got questions. Yes?
I asked about that, but can you maybe go over valid versus invalid substitution?
Oh, valid versus invalid. You do it conceptually?
Sure.
Okay, just conceptually. Sure, no problem. Do you want some concrete example or symbolic example?
Concrete.
Concrete. Okay. Yeah. Maybe, how about just copy things? Okay. Okay, bear with me. Okay, what I would do is I'm going to use one of the previous example to explain. Okay, there we go. Expectation, okay. I'm looking for that intuition thing, okay. Okay, there we go. Okay, so now let's talk about this. Okay, let's see this. So that was the very first example that we used to talk about polymorphism, dynamic binding, right? Let's talk about substitution, since we talk about that. Okay. So now again, those are the three classes we keep talking about, right? So over here you got students, you got resident student, you got non-resident student, right? We know that pretty well. Okay. So now let's say this. We have S, we got RS. Okay. When you talk about substitution, right? Number 4 and number 5. Okay, now you should know very well which one should be valid, which one should not be valid, right? Okay, Andrew, which one should be valid? 4 should be valid, yes. Okay, and number 5 should not be valid, right? So now again, let's think about more intuitively. Okay, can you tell me how you think about number 5 over here? Okay, I'll circle that. Number 5 here. Why is this not valid? Okay, that's a question. Yeah, exactly. That's right. Yeah, that's exactly the intuition. Okay. So okay, let me go a little bit further. Okay. So here, line number 5, we're trying to say RS is assigned to S. So now thinking this way. Okay. S and RS. S in the beginning is pointing to some student objects. And also RS is pointing to some resident students. And more specifically, for resident students, we know that we got something that's unique, which is premium rates, right? So I'll put premium rates over here, okay? So now let's say this. Line number 5 would not be valid, okay? Because if we allow it, something disastrous is going to happen, okay? So let's say this. Say we allowed line number 5. Okay, let's say we allow it. Okay, in that case, RS is assigned to S, aliasing, right? RS is now going to assign to S. Okay, so now, and then as you said before, we know that expectation on RS. RS expectation, how do you do what the expectations are? You can look at its static type, which is resident students. And for the resident student, we definitely got premium rates, we got name, we got courses, etc., right? So now one of them is premium rates. So now, if we call RS.premium rates, which is part of the expectation, what's going to happen? Well, actually, it's going to crash. Simply because when you say RS, which is pointing to the student object, which has nothing about premium rates, okay, it's going to crash. So this is why our initial decision to say we want to allow line number 5 is actually not the case to go. So that's why it should not be valid. Compiler error, exactly, yeah. So I think since we have gone through so many things about polymorphism, dynamic binding, you may just want to go back to this very first example. Just think about what a story is, right? Everything is really boiled down into expectation. And how do you determine the expectation from the static type, right? I hope that answers your question, right? Yeah. Yeah. I would say for the proof of correctness, I'm not in charge of that particular questions for the exam, but I would say review the one we talk about in the class. Make sure you really understand how to judge the base cases and recursive cases. Then in the exam, you should be able to answer them. Yeah. Mm-hmm. All right. Yes. Uh-huh. Okay. It's basically just about some example about instance of and cast. Okay, again, let's now draw some hierarchy here. Let's say we got class A. Oh, actually, let me choose something else. Z, okay. D. Okay, let's say we got these 3 classes, okay? So now let's say this. We know that in order to do cast, you can do upward and downward, right? For as many times as you like. Let's try the following, okay? You can also refer to some previous review sessions. We also talk about cast in some other scenarios. I'll talk about a slightly different example, okay? Let's say this. We have, let me just add one more classes over here. Okay, one more. Okay, so we got 4 classes over here. What I can say is the objects is new M. Okay, that one compiles. And then what I would do is, if I say something like this, can I say something like, let me create one more class for you. another class over here, I. Okay, that'll be good. So now if I try to do things like I, let's say object 2 is assigned to obj. First of all, would this compile? Andrew, substitutions. Would this substitution be valid or invalid? Invalid? Okay, I agree with you. Why should that be invalid? Uh-huh. Yeah. Exactly, right? Object here, static type is simply D, and then object 2 is I, right? Basically, D cannot fulfill for I, okay? Keep it low, please. Okay, so now let's see this. Okay, this one we know that it wouldn't compile. Okay. Okay, that's good. Any question about this? We're okay with this, right? Okay, so let's try another one. Second attempt. What if I say I object 2 is assigned to, since I know that I cannot fulfill the expectation, can I simply say I cast obj into I? I heard no. Okay. Anybody will say yes? What? Would it compile? That's a question, right? I tell you what, there are two parts to this particular thing here. Okay, there are two parts. One is about the right-hand side, which is a cast. And the second part is about the substitution, the assignments, right? You tell me. Aha, so do you think this might be invalid or valid? Invalid, simply because we want to make the answer more complete. Let's say this is a written question on the exam. Can this line compile? If you believe it should not compile, right? Now tell us the answer. Yes, of the static type, right? Okay, good, very good. Okay, let me just write down briefly. Okay, obj here, we know that the static type is actually D, okay, which is here. You can either upcast to here, or you can downcast to either of these, right? These are the only possibilities, okay? So now the reason that this is not valid is neither upward or downward, okay? Neither upward nor downward casting. Okay, so this one here is not valid. Let's try another one, okay? Yeah, I think this is somehow also covered in one of the examples we did, but just doing that a slightly different way. What if I say I, obj2 is assigned to, oops, oh, sorry, there's no M, right? Okay, sorry. What I meant to say was I. How about that? Do you think it might be okay now? Compilation. Yeah, basically we're doing upward and then downward, right? We went through this already in the class, okay? Basically what I'm doing here, that one's a nice review. I think that one there, go to Z and then I. So static type is over here. Go to Z first, and then come down to I. So down, upward and downward. However, what's going to happen? Class cast exception. Well, so now we got to bring dynamic type into play. Okay, simply because over here, what we're going to have is, and I'll get to your original question. Obj over here, dynamically is actually M. But now, somehow by doing the upward and downward casting, now we're casting into I. Can M satisfy expectation for I? No. Okay? So now, for this guy here, the whole thing compiles by class cast exception. Okay? Class cast exception, right? I think this notion about class cast exception is very important, right? And how do you actually link to what we learned before, expectation, okay? Okay, back to your original question. So now, how can we prevent class cast exception from happening instance of, right? Basically, think about every time you want to do some cast, you want to do instance of check, okay? What you will do is like this. But in this way, you're basically trying to do, I want to cast to this and then that, right? So you may want to do two things, okay? Let me try to copy this line here, and I'll put to the next page. Okay, this one we know that it's going to give us class cast exception. How do we prevent that from happening? Okay, something like this. You might say if something like this. Okay, you might say if obj instance of, you do want to do this cast first. I can, you know what, let me just show you a slightly briefer slightly briefer line, okay? Conjunction. And obj, okay, I think that's better. And then I would say obj2 is assigned to it looks a little bit complicated, but it's not quite. Okay. First of all, can you stare at this for a moment? Okay. Basically, I'm just trying to say your intention is to do upward casting and then downward casting. I want to make sure both are valid, basically, right? And remember a short circuit, right? I'm going to do left. If the left is okay, I'll go on ahead to the right. Okay. So now this is what it's saying. Okay. If you think about the cast we're trying to do, you're saying that obj is first going to be cast into Z. So that's why I'm testing for Z. Okay? And then whatever you get from there, I'm going to try to see if that's an instance of I, so you can cast into it. So that's why here you can think about this one here. It's about the result for the first cast. So that's why I'm putting that here. If that's an instance of I, then I can cast that further to I. Okay? That's what's going to happen. Okay? This one is actually more complicated than what you saw in the slides, but it's worth going over.
Just the descendant or just the ancestor?
Just descendant. You don't have that. You only got instance of. That's all you get. Yeah. Yeah, instance of is also quite important, you know, especially you want to do casting. Right? Not just for this course. Yes.
For the second part of the conjunction, do you even need to cast to Z or doing instance of, since it's checking all the ancestors?
Yeah, I think I'm just trying to, yeah, you don't necessarily have to, but I think it's actually conceptually clearer. I'm just trying to show that this is the first part of the cast and then second part, right? I want to make sure both parts are okay. Yeah. Okay? Yeah. Go over in the exam, 17. (16, 17). Okay, you want to compute the average of all the values. Okay, compute the average for all the values that are greater than 10, which means for those values that are less than or equal to 10, you ignore them, right? And then, okay, again, you got parameters, okay? You got return, and also you got precondition. So now that means, yeah, basically precondition, okay, question for you. The precondition tells you x.size, the input list.size is larger than 0. Now, do you have to test x dot size equals 0's case, like an empty list. You don't have to because it's a precondition, right? Okay. Okay, something over here, okay? After testing your code, you're convinced that it is correct and you give it error to using a couple of weeks later. Basically, I tell you what, this one is a bit fancy just to tell you some story over here. Basically, the question is, what's wrong with the method, right? So what's wrong? Okay, let's go over that quickly. Okay, I didn't look at this question before. Okay, you basically just got some average to begin with. Okay, and also you got integer n. Okay, and you try to write a for loop. 0 x dot size, strictly less than size. And then double, that'll be xi. And then you're saying that if xi over here is larger than 10, in that case, you will say n is assigned to n plus 1. Okay, I think n is about how many numbers you have that's larger than 10. Oh, sorry. Yeah, exactly. Yeah. And the average will be average plus xi, which would be the value. And then eventually you will return average divided by n. Oh, interesting, interesting. You know, to be fair, if I were you, I wouldn't spot the errors right away. I gotta look through the options. Okay. Okay, have you seen the error? I've seen the error. Well, I cheated a little bit. I look at the solution, of course, you know, to be honest with you. Okay, let's look at that. Okay, it is interesting. Let me talk about this code together with you. Okay, I think it's worth talking about. Okay, let me move to iPad. Okay. Okay, that's over here. Okay, that's the code. So now, in case you haven't seen what the error is, let's go a little bit further, okay? You can see that this part over here is the second line of the loop body, right? This is the first line. Is it possible that you will never ever execute this part of the code? Is it possible? What would be the case? Yeah, less than 10, right? Yeah, so now for each single iteration, you wouldn't really go to this particular part. You wouldn't go there if the value you're looking at is less than 10, right? What about this? If I got something like this, for example, I got a list, just visualize as an array, 9, 8, 7, 2, and 3. Basically, for every iteration, I'm going to skip this for each time, right? So now, at the end of the iteration, can you tell me what's going to be the end, first of all? How many numbers have I found that's larger than 10? 0, right? Have found no number that's larger than 10. And then this average here would be also 0. 0 divided by 0. Not good. Okay. Okay. Interesting. Yeah, I would say this one tricky, but you got to be careful, right? Yes. Answer A? Oh no, actually, the precondition only says that the size should be strictly larger than 0, so nothing to do with negative, right? So now, let me look at A. You forgot to test the case where x has only negative values. Okay, let me see this. If you only got negative value, apparently you're going to skip this always. I think A should also be correct. I think. Yes. Yes. Oh yeah, again, it's a matter about what's the best answer, right? That's definitely, okay, you know what, I don't like that kind of question, to be honest with you. Okay, You see, I tell you what, if I were the one who designed this question, I would either include A, like a special case, or I would include just E, just to say anything is less than 10. But maybe, I don't know, maybe Burton thought about maybe E is actually more general, right? Yeah. But don't worry, I don't think you have anything like that. Yeah. Yes. Yeah, 0 divided by 0 is undefined mathematically. Yeah, exactly. When all the values will simply make you skip every iteration, right? Yeah, maybe in this case, what you should do is this. You got two options. How can we fix this code? You got two options basically. Either you can say over here, okay, two options to fix this. Okay. Okay, I'll put it here. Two options. Option 1 and option 2. Let's talk about fix. Option number 1, okay. Let's say we want to add a precondition. Oh, thank you. So now option number 1, I'm just copying the code twice, okay, so we can see the options for fixes. Option number 1, you want to add a precondition. So you will simply say add precondition. You can say all numbers are greater than 10. That's one way to go. Option number 2. Oh, you know what? Let me phrase that a little bit. Okay, just for this particular one. Okay, I'll tell you what the appropriate precondition should be. If you read the question again, you're basically trying to calculate the average of all the values greater than 10 in the list. So that means your intention is really to choose between either greater than 10 or not greater than 10. You just don't want to handle the extreme case when all the numbers are strictly less than 10. Okay, so that's the only case you want to exclude. So the precondition will be not all numbers are strictly less than 10. By the way, have you guys learned about universal quantification? 1019, maybe? You know how it looks like? For all? Why don't we try that a little bit, okay, to be a little bit mathematical, just for your information. How do I formulate this particular precondition? Basically, I say it is not the case that for every, okay, we talk about input list, which is X, right? It's not the case that for every I, such that 0 less than or equal to I, less than X dot size. It is the case X at position I is less than 10. Okay, that's for all. Okay, for those of you who know about for all, this might be a nice connection to what you learned in the math course. Okay, I'm saying it is not the case that all the numbers are less than 10, in which case you get division by 0. Okay, that's a precondition. Okay. Option number 2. Oh, for option number 1, you just make the precondition in the Java doc. You don't have to implement anything. Okay, but for option number 2, you have to do a little bit. Okay, I'll write it down. Option number 2. You might say add throws. Throws illegal argument exception, for example, where not all the numbers are less than 10. Okay, that's a purple one. So now, what should we do in the code to really check this? You want to say something like if all the number, if not all the numbers are, how do you implement this though? That means at the beginning of your code over here, you're going to say something like if something over here, you're going to throw illegal argument exception, right? Otherwise, you can continue with exactly what's written over here. You can just continue with this, okay? You can just continue over here. But now, how do you implement this particular condition here? How do you know the for all result? What do you need? How do you know if all the numbers in the list are actually less than 10? How do you know? Emma? If n is 0? That's only a special case, right? But what about, well, how about this? If I give you this guy here, how do you know? You actually have to throw the legal argument exception. How do you know? If n is equal to 0?
Throw the exception.
Oh, you want to throw it at the end.
Can you not?
Yeah, oh, interesting. Okay, I didn't catch you that part. Actually, that's not bad. Sure. Mm-hmm. Yeah, that's interesting. Okay. What I was thinking about originally was to just write in the beginning, which is also fine. Okay, what you're thinking is at the end. That's fine too. Okay, no worries. Okay, so let me just write down this second option you suggest. It's not bad. Not bad. So what you're suggesting is like this. Okay, so we'll talk about option number 2. So now you're just gonna get rid of this guy here. You're gonna say if n is equal to 0, that means no numbers are actually larger than 10. Okay. Guys, can you wait outside, please? I'm almost done. Not done yet. Okay. And then, so now over here, you will simply say throw new illegal argument exception. Argument exception over here. Otherwise, you can just return. Turn average divided by n. Okay, that will work too. Good. Yeah. You mean to initialize n to be 1? Actually, you cannot initialize to be 1 because how do you know? Because somehow the way it's set up is to say every time once you have handled a particular element that's larger than 10, you actually increment it by 1. So unless you change the way you set up the method, otherwise you shouldn't really set it to 1. Yeah. Mm-hmm. Yes. So what? Okay, I don't quite catch you, but I can do exactly what you're suggesting. Might be interesting for everybody to see. Okay. Okay. Since I've got another option here for everybody. Okay, what should I change?
So just outside of the for loop,
Yeah.
just doing an if statement, checking if active.
You mean after the for loop or before the for? After. You mean after this, right?
Before the return.
Before the return. Okay, you mean okay. What should I do?
So just putting in a for loop, checking if x is equal to 0. If it's equal to 0, just change x to 1. Set x equal to 1.
Change x to.
So then you wouldn't get here.
I don't exactly get. Okay, so you're trying to you say what a for loop?
So no, put an if statement.
If statement. Okay, what do I say?
So x is equal to 0, so x equals to 0.
But x is a list, right? You cannot say x is equal to 0.
No, x n.
If n is equal to 0. Isn't that what we did?
No, but just n equals 0, and then just put n equals 1. Set n equals 1 instead of 0.
Okay, if n equals 0, and then what do you do?
Then we assign 1 into n.
Okay, and then you assign 1. Okay, sure. And then you will say n is assigned to 1. Okay, and then what do you do?
Then wouldn't that just fix the return statement? So you get 0 divided by 1.
Oh, I see what you mean. But the thing is, okay, yeah, you're just trying to avoid having the exception.
Yeah.
You're basically hacking the code. Okay, yeah, that's okay. Okay. I tell you why. It might be okay, but it's bad. Okay, yeah. Okay, that's okay. I'm glad you suggested this. Okay.
The other one, what do we have to do? Throws.
Okay. It's not okay. Throwing an exception is not a bad thing as long as you throw it for the good reason. The reason that we want to throw an illegal argument exception is because conceptually, if n is simply equal to 0, that means there's no value that's larger than 10 for you to calculate the average from. In that case, you're getting division by 0, so that's an error. Mhm. Yeah. Yes, but in your case, let me just talk about in your case, okay? In your case, you basically say return over here, average divided by n, okay? Apparently, in this case, average will just be 0, right? N will just be 1. So now 0. You are kind of misleading, okay? So now you're saying that I have no values that's greater than 10 in this list, but the average is 0, right? That's not right, yeah. Even though you don't have exception, but the value you return is conceptually not correct, right? It should be undefined, yeah. Negative 1?
Yeah, if you return -1, like
Well, again, I would say in this case, you don't, conceptually, if you have no values that's greater than 10 for you to calculate the average for, the value should just be undefined. So if you return -1, it's like a defined value, so it's still not appropriate. Right. Yes? Question 23, sure. Yeah, no problem. Okay. 23. Okay, let me take a look. Deck of cards over here. Okay. Which of the following is the most accurate explanation of what is printed by the program above? Okay. Okay, deck of cards and okay, it's like a copy constructor, it seems like, okay. And deck of cards. Basically, he's trying to make a copy of the card, first of all, right, from this line, by using the copy constructor. And then he's trying to return the cards from both decks. Oh, basically, he's trying to make a copy of the deck first, and then try to return the cards from both decks. And then he's trying to see, according to the equals, now, here's a problem. What's the type for deck of cards? It's basically a set of cards, right? Now, in order to know if the two sets of cards are really equal, it depends on the equals method in the card. You see what I mean? Good. So now, it will simply say it will be true if both cards are the same. Let me see why other option may not be so ideal. Okay. Again, you know, it's not exactly my style for asking questions. Let me just read it through. Okay. False. Is this like a continuation? Oh, it's actually from 22, I see. Okay, I didn't notice that. Okay, that's from 22, right? So 22 over here. Okay, you can see did we actually, oh. Okay, so now it's even easier. So now that means when you compare two cards, what does it really mean? They are equal. If the equals method is not overridden. Yes, the same, right? Oh, I think maybe you're a little bit bothered by same as. Would that be the thing you're being bothered by?
Yeah.
Okay. Okay.
Right? So
He's going to compare addresses for the card.
Yeah.
Okay, first of all, okay.
different objects.
Yes, different objects. So now, remember for JUnits, we say assert same and also assert equals. Okay, if I say object 1 and object 2, and also here we got object 1 and object 2. Let's review that a little bit, right, since we talk about it. You don't have to write them, but you should really know how to read them. So this is equivalent to O1 equals O2, right? Just compare the addresses. So now I think that's what he meant over there. It's not the same as, okay? On the other hand, when you say assert equals, it's O1 dot equals O2. So now, which version of the equals method will be called depends on if you have overridden it. If you have, you will call that overridden version. If you have not, you're going to call the object version. Okay. Make sense?
Yeah.
Good.
So what I'm saying
Yeah.
is since it's not overridden, right?
Yeah.
So what does that mean? So the object
Mm-hmm.
the equals
They're going to compare, yes, they're going to compare their references.
right.
So now I think that what we should really check is what they return when they say get cards, right? Not shown, but returns either an alias or To be honest with you, I'm not too sure what he's trying to. Okay, so here he simply get cards. He would say in permutation not shown over here, but returns either an alias, which means just return the cards directly, right? We're trying to make a new copy of this. Okay. Yeah, exactly. You can assume each one. You can assume either one. It can be both, right? It can be either one. Contains different cards. Then I would say you don't have to worry about this. To me, it's not very clear. Yeah, but don't worry. You know, anything that's like this is not there tomorrow. Yeah. 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 Yeah, it's going to compare references only. Correct. Mm-hmm. Okay, guys, just give us a few more minutes, okay? Mm-hmm. Yes, I agree with you. So basically, what's going to happen, at least we know. In this case, because we know the equals method was not overridden, so it's going to call just use the object version equals. So now it really depends on whether the copy cards over here is an alias or is like a copy, right? That's the question. So that's why this question is not exactly straightforward. So I would say it seems like, yeah. But I would say don't worry too much about it. So I think in the exam, at least for the ones I review, it should be very clear to tell you which one is happening. Yeah. Okay.
I think C is true because
Yeah.
if you're calling equals on a collection,
Yeah.
it's comparing every single element, and each card is an alias, whereas each deck of cards is a new object.
But how do you know each one is an alias? Is it?
I think in the
Is it?
when it adds cards, it's included.
Yeah. Yeah, you know what I'm really bothering me over here is about the get cards.
It simply adds card rather than creating new cards.
Yeah, sure, but when you get the cards, right? But how do you return the get cards? Maybe you simply make a copy of every card you're returning. In that case, the equals, if you're comparing addresses, it would be false.
But doesn't it say you can either return an alias?
So that's why we don't know, right? So implementation here is being too flexible. You don't know which one is happening.
Yeah, but like with all the options, if you consider either one, then C would be the only one that works.
No, but consider either one, two of them. Because if when I got it, it gave me a copy of the cards, then none of those cards are the same card.
Okay. Yep. You know, to be honest, I'm not too sure about this. So I would say don't worry about this question here. Yeah. Yeah. Guys, do you want any more time? Or you're fine? You're fine? Well, I would say don't be too bothered by this question here. Yeah. If you're really still bothered by that, you don't have to. Okay, we okay? Okay, best of luck. I'll see you there tomorrow.